Right. What time is it now? 8:08. All right, officially, I'm getting started speaking. Welcome to Automating HPC Research Workflows on Perlmutter. This is a seminar about trying to use workflow management tools on high-performance computing. So there is a prepared GitHub repository with everything you need for all of the examples and documentation and some other stuff, the environment. That link has been up here. Hopefully you've gotten that. It will also be in chat and other places. Clone that on Perlmutter, load the Python module, cd into the directory, and create the environment. Yeah. Oh, well, this wouldn't be a better screen for saying that. There's no detail here. Okay. So this is approximately timed for 4 hours. I have not been able to exactly time it, so there's going to be some on the fly, but we've also got flexibility if it turns out that people want more specifics in some area or less specifics in another. We've got some wiggle room as far as time is concerned. The repository is set up so that running all of the examples, starting out with something that you can just go on the machine and it works, and then modify it for yourself beyond that point to learn more. I have put a lot of energy into setting that up to work under conditions. I did not have the training reservation that we have available today when I was setting that up. So I may have missed a string or a spot or a typo at some point for actually using the reservation. And hopefully we won't trip over something like that. But if it comes up, we'll find it and we'll sort it out. All right. Again, there's the link with the repository. Git clone that and get started. It's got the software environment, all of the documentation, all of the actual example scripts, what goes into them, what kind of output you should expect. And there's also some utility script kinds of things. I've included cleanup scripts, which will take care of artifacts that are generated by examples if you want to run them more than once and don't have things collide into each other. They're not super smart, so if you start changing things, then the script might not get the new parts that come out, but it's still pretty helpful. Yeah. I believe I'll be able to handle questions at any time on the fly so that we make sure everything lands in context. That may be hubris. I'm not sure yet. There are a lot of people here. So if things do get a little too frantic in that way, then I'll dial it back. But at this point in time, I think that we can be open and interactive like that and still move forward. All right. So the actual agenda plan. I am on Pacific time. It is 8 a.m. and an unseasonably rainy day in Berkeley, California. Incidentally, we are in building 59. So if you happen to be at the Lawrence Berkeley campus, and we've got some extra chairs in here. If you want to just walk down, I think it would be helpful to have a person in here other than Madan. But that's just something that we can do. So the first tool will be GNU Parallel. We'll spend half an hour on that. Second tool is called Signac. There's breaks in between Maestro, Merlin, and all right. I have never heard the name of this tool pronounced in my memory, so I do not know exactly how to pronounce it. I am going to say IDA. There may be someone in the chat who can correct me, and that would actually be welcome.
Iyad, yes, thank you.
IDA?
Iyad.
All right, thank you for the thank you. Yeah, it is a strange disconnect to move from reading about things to speaking about things, and little bits like that can fall under the cracks. All right, so background knowledge. What are we presuming that people already know coming into here so that we're not repeating too much? All right, Slurm basics. This is the job scheduler that we use on Perlmutter. There is SBatch for submitting batch jobs. There is salloc for getting an interactive terminal on a compute node. SQ for seeing what the queue has about your jobs right now. I tend to use SQS also, which is like a little in-between wrapper thing that's a different shaped SQ, but all right. Shell scripting stuff. Hopefully you already know about bash, about redirection and pipes, common Linux tools. You could grep something, you can open up a text editor for a file and see what's in there, that kind of thing. Python basics. Looking at a Python script and being able to figure out roughly what it's doing. Recognizing function calls, recognizing decorators added. And some broader HPC concepts we're assuming you already know. What's the difference between a node and a core? What's the difference between running things in parallel versus running them in serial? How does batch schedule actually work? What's the point of it? What's being subject to batch scheduling going to do to your work? All right, on to some content. So, why does this entire category of workflow management tools exist? Research that uses large computing resources, high performance computing, can generate a very large amount of data, of artifacts, of files and directory and pieces. You're doing parameter sweeps, you're running pipelines, there's intermediate files, there's ensemble studies, there's lots of stuff. And you need to keep it organized to actually be able to approach it and use it to do research. When you're actually starting a script, usually things will start smaller. You're just figuring out this new process you want to try or this new idea you want to do. And the managing at that scale might not be the top of your stack of things to worry about. So you might just start with a script that's submit.sh that you send to Slurm, and that runs your one thing. You might add a bash loop that submits 10 of those because now I want to run to 10 of those. It's just a little bit more. You're naming your own directories. You're organizing your experiments with like, oh, well, I'm going to type the date that this ran on the name of the directory, and then in the next directory over, that's going to have another date. But it's not perfectly consistent as far as a computer is concerned. So, a human has to go in and look and figure out where did all this stuff actually go. And the main pitfall of all workflow management tools, even if you do go out looking for something, it's an overwhelming selection, and lots of people will fall back on, well, I couldn't find what I wanted or needed, or something wasn't exactly right, so I wrote it myself. And that's one of the main reasons why we have so many workflow management tools, is so many people needed or decided to write it for themselves. As your experiments get bigger, as you have the need for more and more data and runs, and replicates and on, this human management gets brittle, it's harder, it can break down. If you're doing a combinatoric study of a parameter sweep, just adding a few more pieces, and that could add millions of new combinations and directories that need tracked that you're not going to be able to use with just your human typing in things to make directories previous system. If you've got pipelines chaining tasks together and your inputs and so on, adjusting those pipelines gets more and more complex. You have to remember what the state was before and after, and if you had sort of any API dependencies or requirements, or was there a gotcha at this step. Edge cases and failures pop out at any point, and that compounds and compounds. You have to spend more and more attention doing the plumbing of keeping your thing working, and less on the actual science that you want to be thinking about. If tasks fail for whatever reason, maybe your application has, a 1% chance of something just goes wrong. Maybe you're using enough compute nodes that the chance of a node failure might actually get you sometimes. Going into logs and error records, actually finding the tasks that failed, being able to rerun them, figuring out where they fit into the pipeline so that you know that you're pulling in the right input and your output is going to the right spot that go into the rest of the pipeline. That also takes more and more attention. And what if you want to go back and pay attention to something that ran 6 months or a year ago? If you didn't pay attention to record keeping and organization when you first set things up, or you didn't have some kind of consideration for maintaining that, you may have a very hard time doing the software and data archaeology to go back and find some very important thing that happened 6 months ago. The workflow management tools exist to solve some or attempt to solve all of these different problems and others. One of the biggest things to focus on is you should be consciously thinking about which of these problems you definitely care about, which of these are nice to have, which of these problems do you think you will need in the future, but you don't yet because you haven't scaled to that point. And plan again so that you can choose tools that will actually cover the bases that you need and have that prepared in advance. Because there really are a lot of automation pieces that can effectively solve these individual problems and be composed together to solve all of the problems that you need. And suddenly all of your attention is opened back up to the thing you actually want to be thinking about. That choice of workflow management tools that I mentioned, it truly is at an absurd scale. I have a spreadsheet where I have tried to catalog every workflow management tool that I can find, and there are at least 500 different tools out there. Things from cloud space, things from HPC space, things that are just simple job runners, things that are doing all of this tracking. Lots of them come from bioinformatics, so lots of them have sort of this cultural presumption of the conditions in like next generation sequence analysis. On and on and on and on. So many different tools. Yeah. Oh, this is just a line about more of the different. They have different operation setups. Some of them need more support infrastructure than others. They have different interfaces. Almost everything has like a Python API, but some things don't. Some things expect you to use a particular language. Some things expect you to run particular databases or have somewhere to put a web interface or something like that. They all have sort of different scaling curves. They all have different things that they're very good at, and some things that you definitely should never use it for that because it's going to be terrible at that. And this is the layout of the space that you also need to have some awareness of if you're going to be picking tools. Yeah, because it is really easy to put in a Google search when you first realize that, oh, I need a tool and there might be something out there, and you come up with 100 different options and you grab the first thing that seems okay, and you might get lucky and that might cover everything you need. It's probably going to do some of the things you need, and some of the other parts are still going to end up doing by hand. But just out of reach, there might have been that thing that does everything you need, and you missed it because there was this sort of tragedy of too much choice. Right, so there's 5 tools today. That's less than 1% of what's, that's less than 2% of what's available, because like 250 tools have died due to bit rot over the past decade or two. So the real population of things that might come up is like 250, but it's still a tiny fraction. Don't lose hope as a result of that. Imagine that this is like case studies and you're picking out individual characteristics of tools to pay attention to, things to look for when you first see the documentation, so you know, oh, this is a Python tool. Oh, this is a tool that's keeping your workflow state in a database that has to run somewhere else. Oh, this has this characteristic, that characteristic, and then you can map that to, oh, this is going to solve this problem, this is not going to solve that problem that I have, and on and on and on. All right, so the actual arrangement of content we're going to look at today. We're going to start with the absolute base, simplest thing, and then we're going to add a little complexity and we're gonna add a new capability for each new tool. And we're gonna step and step and step until the most powerful tool, but also the most difficult to operate tool, Ada, is gonna be at the end. So, very base front, starting with nothing, no tool. You have a job, you type on your Vim, you write your job script, you put it in one at a time. When it's done, you look at the result with your Vim or whatever, and you put it in a second S batch. You're the workflow manager, nothing is being automated. You're not really necessarily going to get parallelism unless you write 2 job scripts, which you could do by hand, but you're not going to write 1,000 job scripts. That would need something else. And the organization of this is also something you're doing yourself. You're naming your files, you're choosing your directories, you're choosing your working directories and where your intermediates go. You're setting all of that yourself. And human typos and errors and memory being flawed, you're subject to all of those potential problems. All right, first tool, GNU Parallel. It is just a shell command that runs a bunch of independent tasks in parallel. So something that is shaped like a Linux command, you can put into GNU Parallel, and you can give it a system for substituting the arguments that you give it, and it'll run all of those on one node. So now your 1 case to 100 case or 1,000 case got a lot easier. It'll run stuff on the cores of a node easily, and it's not gonna cover those other things like organizing your intermediate files. You can't have any data dependencies, like if you need one task to finish before another builds, GNU Parallel has no concept of that whatsoever. It's not trying to do that. Don't try to do that. It doesn't coordinate multi-node allocations, and it doesn't track any of the history beyond just sort of a rudimentary log. The next tool after that, Signac. So the thing that Signac adds is you give it your set of parameters that you want to sweep and the dimensions, and it will go out and it will build the directory structure for you. So it's deterministic in how it does that. So you could take the same set of parameters to any system and you'll get the same directory tree. And now that's another part of automating your work that you don't have to worry about. It's also, you add Signac Flow and it gives you tools for examining that directory structure, filtering out pieces, searching, aggregating, like, find me everything that had temperature 300. And this also adds a Python API functionality. Also, Signac lets you rerun things and it understands if the output is already there, so it doesn't need to rerun it. Okay. Next step after Signac is Maestro. Maestro lets you add data dependencies. So if you have a pipeline of things that A needs to run before B needs to run before C, the previous 2 tools have no conception of that. Maestro can let you specify that. To work with Maestro, you write YAML files, yet another markup language. But you can do parameter sweeps, and you can do in like fan out, fan in, or scatter gather, depending on which words you use. And it's got improved Slurm integration. Signac has some Slurm integration. GNU Parallel has effectively none. Yeah, multi-step pipeline. That's the first tool we'll go for. The step after Maestro is Merlin. Merlin uses a message broker service that runs somewhere else to preserve the state of the workflow. So this is how you keep track of what's going on if you need more than one job allocation for some reason. If your actual application runs need months of stuff stitched together in different jobs, Merlin has a service that preserves that information between it so you don't need to track like, oh, well, what was the last job ID that I ran? Where did the output for that go? How do I feed that into my next one? So with Merlin, you dispatch workers that will take a look at what's in that message broker queue, because that's where you keep the jobs that are pending, and it will pull those out and it will run those wherever you set up your workers. We're gonna do it there in a Slurm job. And that's how you sort of bridge both different places on the system, different compute nodes working together, and over time during a long campaign. It's got improved fault tolerance, so it understands both completely retrying if something fails, and it has the ability to understand if your application can checkpoint and restart and issue interact with those features. Also, because it's not a single process managing everything, it's got both the sort of the core piece and the different workers, it scales much better because, an example from older software, Task Farmer was a workflow management tool where you would have your process and the process would be dispatching jobs off into the queue. And you would be limited to about 50 tasks in flight at a time, because that's how many connections the manager can actually keep active while they're running. Merlin gives you the ability to have more workers than just one interacting with things, so that's how you get this fan out and you're able to have many more tasks in flight at the same time. So if you need to scale very large, then this is the kind of feature that you need in your workflow manager. All right. Last tool, most complex and capable tool that we're going to talk about today. Ada does everything that we've discussed earlier, and it also has a built-in system for recording all of the details of every job. So all of the inputs, all of the arguments, all of the parameters, the software versions, all of that gets preserved by Ada, and then it keeps it in its own graph database that you can search through. You can figure out, like, when did my pipeline actually upgrade from Python 3.11 to Python 3.12? This can help you actually answer that question without going back and doing forensics and archaeology. That graph database history, there's also features here to export that. You can visualize it. You can turn it into charts and include them in publications or in your quarterly reports to your funders or whoever else you need to prove that this is what we did, and we have very good records for all of the work that we accomplished over the time that we've been running our workflow. It also understands when outputs already exist, and it doesn't need to rerun them. So this is the right tool if you have all of those earlier needs and you want to have a very clear and usable history of everything that you've run over the history of your project. Okay. Tool selection. There are questions to ask to narrow down how you make these decisions. Are my tasks independent, or do some of the tasks depend on others? Do you need something that offers directed acyclic graph ordering of tasks or not? That's what this question answers. Lots of tools offer DAG support at this point in time. Fewer don't. But if you don't need that, then you may be able to save some time by using a simpler tool. That's the point of asking something like this. How many inputs do you have in total? Is it okay to do it by hand because there's only 20 of them? Or do you need something that's going to organize all of your inputs for you? Is a unit of your work going to fit in a single Slurm job or not? Our maximum wall time is generally 2 days. If you can get things done in 2 days, then you may not need a persistent workflow state storage kind of tool. You may be able to get away with something that's more ephemeral. That's what this question is about. How many total tasks are you going to need at a time? Total. how much more might it be useful to have? How big do you need to scale in total? If it's, if you're not ever going to get past thousands, then you can get away with simpler tools that maybe only have one manager process, and it's easier to wrangle the system. If you need to go much larger than that, then you probably do need something that's operating a persistent service that's tracking your history, tracking all of your jobs in flight, that kind of thing. And yeah, how much do you care about the history of what you've done before? Do you need to preserve every single positive and negative result and be able to search back through it and share it with other members of your team or people outside of your team? If you expect to need to do a lot of that, then having something that is taking care of the provenance behind the scenes is going to help you. And a last point about this, most of these tools are not mutually exclusive. You can use more than one tool at a time. The general pattern there would be you're probably going to want to include simpler tools inside the tasks of more complex tools. So like GNU Parallel inside a Maestro task is a plausible thing to do. And you can, by doing that, get the benefits of both of these tools and sort of avoid some trade-offs. Like you can get a little bit more scaling by putting GNU Parallel running 100 replicates inside each of your parameter sweep points. That's the kind of thing that you can piece together with these. All right, plan for this section. So open up a tool, we're going to talk about motivation, the core concepts of the tool, and then we're going to go to the 3 examples for each one. We start with like a core mechanic, absolute minimum viable, get this thing to work. Second example is going to be something that's closer to a real situation, although we're not going to like really do big scale for anything, but it's going to at least have the shape of something more real. And in the third example is we're gonna start using Slurm and see how that goes, or make something that is actually a bit larger. Cross fingers, all of these examples should run off the shelf on Perlmutter once you've cloned the repository. All the payloads inside the tasks are synthetic. We don't care about what's actually running for the purpose of this teaching. We just want to get that outer framework working and understandable. And there's a cleanup shell with each of the tool sections. So if you want to rerun an example and you don't want to get confused about what was from previous runs, then this should help. All right, so hopefully people have the repo cloned and the environment created by now. You start the environment with conda activate, WF seminar, and then there's some Python imports that you can test to just verify. That doesn't include GNU Parallel because that is just part of the stock image that's available on Perlmutter. I should make this bigger. Yeah, I've got some windows ready to go. Oh wait, I need to load the module first. Yeah, here we are. All right, so I got my environment ready to go. So if any imports fail, there is more information that you may be able to help debug something on your own. Hopefully we never get to that point, and I've already failed if we do, so I apologize. But you may not be completely stuck if you can't get my attention while we're talking and some sort of pip install didn't work when building the environment. So everybody who is registered should have been added to this ntrain3 account that will get you onto the system and into the reservation. And this is sort of what you add to your SBatch to actually use that. So we have some CPU compute nodes set aside for people to use while we're working today. I did not look at when that reservation actually ends. I wouldn't be surprised if it ends at noon, but maybe it'll go till the rest of the day. But a lot of this stuff, once the reservation is over, switch to using like a debug QoS or interactive QoS or something like that, and you'll still be able to get reasonable throughput. All right, questions about where we're actually going to run things. Please use the reservation, although it's like that's for your own good advice kind of thing and not completely necessary. We've got enough people, we may fill up the reservation. And in that case, I ask people that do have other NERSC accounts to switch to that and go into debug or interactive to free up room for people that don't have NERSC accounts and our guests. But I don't know if we'll actually get to that point, since all of the stuff that runs hopefully shouldn't take too long. Please don't get an SALIC for 4 hours and just sit on it the whole time. Limit yourself to actually having one of those nodes when you're directly using it. There are a few things that's fine to run on a login node. Really the things that don't involve any services at all. So if you don't run the Redis on the login node, that's probably going to be a problem for you if you try. Because they're all set to use the same port. So if two of you try to use it on the same login node, then you're gonna have one of you is gonna have something that doesn't work. And there's the potential to leave the Redis process behind once you go home for the day, which will be annoying to clean out, but it'll have to sit there until the next login node reboot. Another pretty core thing to point out, this is not a spin training, but the more advanced tools here, basically the right way to run them in production is to put their daemons and services in spin. So this is like a get familiar with it in the easy running environment, but then you should go take a spin training and get a container version of these things and set up so that you can run that properly. Sort of the reasoning behind this is login nodes are not a good place to run services long term. Sometimes they need to be rebooted. Sometimes they'll get jammed up because a user runs 1,000 Python processes on it, or does a lot of bad file operations, and so the connection to DBS goes bad, or they're not reliable. You won't be able to depend on a persistent service staying alive on a login node. There's also a load balancer, so you don't necessarily know which login node it's going to go on, and then you have to pay attention, like, oh, was that login 21 or login 22 where I put my Redis? There's a little bit of firewall stuff, and like there are some known public services that we might intentionally block the ports because we don't want people like running an open Postgres on a login node or something like that. For those reasons, things like that should go on Spin, because Spin does have some ability to guarantee reliability and continuity and control over the network conditions and protection from being interfered with by other users.